Hey, what's up, guys? Mr. Flores here. All right, and this is a video that's dealing with factoring quadratics where a is greater than 1. Okay, aka the leading coefficient, the coefficient of the x squared term is greater than 1. Okay, and basically what this is I know in some of the other problems that we did in the last video and the last lesson is that the leading coefficient was greater than 1, but we were to factor it out because that was the GCF of the whole term, of the whole expression. Okay, because we could factor out the 2 and it became a 1 and it was easy. We could factor out the 3 because it was common and everything and it made it easy. Okay, but if you look at this problem, we have 3x squared plus 11x plus 6. Well, we can't really factor out a 3 because it's not a common factor between 3, 11, and 6. There's actually no common factor. So we can't simplify this at all by factoring something out. Okay, so this is when factoring quadratics gets a little trickier. Not hard, just trickier because there's more steps. There's a couple different ways to do this. The way I like to do it is it's called the box method. Again, it might not be the easiest, it might not be the best, but it's the way I like to teach it because I feel like kids understand it. If you want, I can show you other methods. I might end up making videos for the other methods of doing it, but for this video, it's called the box method. Okay. The way you start it out is you must take your first term, which is 3, and multiply it by the last. Okay. So that's going to give us 18, because 3 times 6 is 18. Then we need to find two numbers that multiply to that are going to add to the middle term. Okay. So just like the other way, you need two numbers that are multiplying to 18 and adding to 11. The way I got the 18 again is I took the 3 multiplied by the 6. Okay, so we know that those two numbers are going to be 9 and 2. Okay, now this is why it's called the box method. Because what I'm going to do is I'm going to build a box. Actually, I want to make it a little lower. So I'm going to build a box. And then inside that box, I'm going to put 4 other boxes. Okay? So in the top left, you're going to put your first term. So 3x squared. The bottom right, you're going to put your last term. So 6. Okay. Then in these two empty boxes, we're going to put these two numbers that we found. It doesn't matter where you put the 9 or where you put the 2. Just make sure you put them in there. So I'm going to put the 9 here, the 2 there, and all you do is add an x to those two numbers. Okay. So I got the 3x by the first term, the 6 by the last term, then 9 and 2 were the numbers that gave us what we wanted. I put them in the other boxes and gave them an x at the end. Okay. What you want to do now is you want to find the GCF of these two boxes going left to right. So 3x squared and 9x is the GCF of 3x. 2x and 6 is a 2. Okay. Then vertically, 3x squared and 2x has a GCF of x. 9x and 6 has a GCF of 3. Okay. So our answer, when we factor it, is going to be 3x plus 2 times x plus 3. All right? And if you, so this is our final answer right here, 3x plus 2 times x plus 3. If you happen to check your answer, aka by foiling, you should get back to your original answer. 3x times x is 3x squared. 3x times 3 is 9x. 2 times x is 2x. 2 times 3 is 6, which simplifies to 3x squared plus 11x plus 6, which is what we started with. So therefore we know that this is our answer. Okay? And that's all the box method is. The box method allows us to factor a quadratic where a is greater than 1, which we can't factor out a GCF. Okay. Again, it's a little trickier, but again, it's not hard. So we're just going to do some to practice, and we'll see how it goes. So we look here, we have 2r squared plus 9r plus 10. All right. Hopefully we wish that this could become a 1 because it makes your life easier. But we can't factor out the 2 because it's not common between 9 and 10. So what you first have to do is multiply the 2 times your 10, which is going to give us 20. Okay, so we need two numbers that multiply to 20. Those same two numbers have to add to 9. Well, if we know our multiples of 20, we know it's going to be 5 and 4. It's going to come out nicely. Okay, so once you find your numbers, that's when you build your box. So again, in the top left, you put your first term, so 2r squared. Bottom right, you put the second term. Then you put the 5 and the 4 attached with an r in these two boxes. Again, you could have put the 5r here, the 4r here, wouldn't have mattered. Now all you do is you factor out the GCF of them going sideways, factor out the GCF going vertically, and you're good. So 2r squared and 5r gives us just an r. 4r and 10 is just 2, because the GCF of 4r and 10 is 2. GCF of 2r squared and 5r is r. The GCF of 2r squared and 4r is 2r. The GCF between 5r and 10 is 5. So your final answer is r plus 2 times 2r plus 5. All right, and again, if you were to FOIL this out, it would go back to 2r squared plus 9r plus 10. All right, so this is your final answer. Again, and this is the box method. There are other methods, but this video is about the box method. All right, so we got to look here. We have 3x squared plus 17x plus 20. Again, if we could factor out this 3, that'd be ideal, but we can't. So what you do is take the 3, multiply by 20. So what times what equals 60. What plus what equals 17. All right, so this one's trickier because there's a lot of factors of 60. We could do 15 and 4. We could do 20 and 3. The one that's going to give what we want, though, is going to be 5 times 12. Because 5 times 12 gives us 60. 5 plus 12 gives us 17. Once you find the ones that fit, that's when you build your box. This is why it's called the box method, because you build a box. All right, again, in the box method, we put in the top left the first term, bottom right the last term. Then I'll put 5x here, 12x here, and you just factor out GCFs. The common factor between 3x squared and 12x is 3x. 5x and 20, the GCF's of 5. 3x squared and 5x, the GCF's x. 12x plus 20, the GCF is 4. So our final answer is 3x plus 5 times x plus 4. All right, hopefully this is starting to make sense. Again, the box method or the harder methods of factoring are used when you cannot factor out the leading coefficient. All right, so we have 9x squared minus 15x minus 6. Okay, so again, the first thing you always want to look at is, can you factor out a GCF? Well, if we could factor out a 9, that'd be ideal, but we can't. But if you look closely, we can factor something out. Whenever you factor, you have to pull out a GCF first. If you can, you must do it. If you can't, oh well, you keep going on. So the GCF between 9, 15, and 6 is actually going to be a 3. So when you factor out the 3, you're left with 3x squared minus 5x minus 2. Okay? So now, the only difference between this problem and the last couple ones we did is that we have a 3 out front here. You still follow the same pattern. Since we can't make this 3 become a 1, we must multiply the 3 times negative 2, which gives us negative 6. So we need what times what equals negative 6. Those same two numbers have to add to negative 5. Well, the factors I want to choose are going to be negative 6 and 1, negative 6 and 1, because negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. All right. Once you find the ones that work, you build your box. All right. Again, in the top left, you're going to put the first term here. Don't go back to the original problem because we factored out the 3, so now we're working with this. So it's going to be 3x squared up top and negative 2 bottom right. Then it's going to be negative 6x, and then we'll just 1x. And now we have to factor out whatever we can. Okay, so when we factor out this way, it's going to be 3x squared and x is just x. Negative 6x minus and a negative 2 has a GCF of negative 2. 3x squared minus 6x is just 3x. All right. Then x minus 2 is just Well, a positive 1. Okay, so when you write your final answer, it's going to become 3x plus 1 times x minus 2. But if you remember, we pulled out the 3 in the beginning, so we must still pull that out. And our final answer is going to be 3 times 3x plus 1 times x minus 2. All right, and again, that is the final answer. Okay? Again, I'm going to do one more, all right, and we'll see how it goes. So we have 4x squared plus 8x minus 5. If we could factor out a 4, that would be ideal. But we can't. So what we got to do again is you multiply this 4 by the last term, and you're going to get what times what equals negative 20. Then those same two numbers must add to a positive 8. All right. So if we look, we're going to get positive 10, negative 2, positive 10, negative 2. We found out what works, so we build our box. Again, the top left, you're going to put 4x squared, bottom right, negative 5. I'm going to put 10x here, negative 2x here, and you're just looking for GCFs. The GCF between 4x squared and 10x is 2x. GCF between negative 2x and negative 5 is a negative 1. The GCF between 4x squared and negative 2x is just 2x. The GCF between 10x and negative 5 is a positive 5. Okay, so your answer is going to be 2x minus 1 times 2x plus 5. All right. Again, any questions, let me know. Hopefully this works. It makes sense to you. Again, if you're still having crazy trouble with these complicated factoring ones, come see me and I can show you another method to use. All right. If you have questions, let me know. Again, factoring is one of those things that doesn't go away. If you're good at it, it makes your life easier. If you're not good at it, well, practice and you'll be good, because practice makes you better. All right. Any questions, let me know. Watch the video, do some of the worksheets, and have a good one.